In this recording, we want to review how to use residual plots in order to analyze a good fitting model for regression. What we see in front of us is a set of data that compares SAT scores to college GPAs at a certain university. What we're going to do is to go ahead and do a regression analysis on this. So we'll start by making a scatter plot. We'll start with the SAT total and the college GPA and see if we can find a relationship between these two. I've chosen the data. I'm going to insert a scatter plot. I'm going to adjust my axes so I can see this better. It looks like a 2.0 is a low enough GPA for this. And adjust my x-axis. Looks like 1,000 SAT score would be low enough. And we see our scatter plot of the data. Now there doesn't seem to be much of a pattern here, possibly something positive, but they're pretty scattered. This is going to be a pretty weak relationship that we see here. So we'll go ahead and add our trend line. I'll just right click on one of the points. I'm going to add a trend line. I want to display the equation and display the r-squared value. And I can see from the r-squared value, only about 16% of the error has been taken care of because of this model. So we haven't really accomplished a lot, but it's okay. So we'll go ahead and move this here. And by the way, I'm going to ignore the predicted GPAs that we have here. We're going to compute our own. So going to the data tool, we're going to use the data analysis tool in order to do a residual plot. Now, if you don't have this, again, you find it under File, you go to the options, you choose the add-ins. Within the add-ins, we want to choose the tool pack, so you can do that pretty easily here, and you choose the different analysis tool packs. It should show up under the data tab. We want to do a regression analysis, so we'll bring up data analysis, go down to regression. And as we've done before, we want to include our response variable, our y variable. So I'm going to click on this icon, choose my GPAs as my response. My explanatory variable was the SAT score, so I'm going to choose those SAT scores. There were labels in the data, so I want to make sure that Excel knows not to include those in its analysis. I'm going to go ahead and put my output. So I'm going to put my output in here. I'm going to just choose a cell like over here to the side. And then I want to tick the box for residuals and residual plots so that we can take a look at these. So I'll go ahead and allow Excel to do the analysis. Looking at our output, we see our r-square, 0.1597, just like on our sheet. We go down, we can see our intercept is 0.2733, as we see up here as well. And our SAT total, 0.0021, becomes the slope for our model. Now, if you use this model and actually put in one of our explanatory variables, like the 1234 SAT total, the predicted value comes out in these residuals. So that's what we see down here. The software has done all of the predicted values using our model. And what the residual is, it's the error between the actual and the predicted. So to get a residual, basically all you do is you take the actual, our actual GPA of 3.42, subtract the predicted, and we got a residual of almost 0.5. If our actual value is larger than the predicted, we'll get a positive residual. If our actual value was lower than the predicted GPA value, then we'll get a negative residual. The sum of these residuals should be 0. We can actually work that out here. Let's see if we can do a sum equals sum. And let's add these residuals up to see. It should add up to 0, and that's basically point, and we have 14 zeros and then a 4, which is basically 0. So there's some round off error, but that's basically 0. So that's our residuals. we do a residual plot to see how good a fit we have. So if I look at my plot over here, what the residual plot basically is it's taking the scatter plot, and where our trend line is, it's going to turn that horizontally so that we can see the points above and below, and it allows us to see what kind of error we have. What we want to have happen is we want this to be random. We want a random selection of points above and below this line. If it's random, then our model is probably a pretty good fit. So this model, even though it's weak, is the best fit that we're going to have for it. There are other possibilities for models. So for instance, I have a couple of residual plots we could look at here. Here you can see in this residual plot, I've got a curve going on. So a curve would actually be a better model than a linear model. And in this case, I might want to choose something like a quadratic model rather than linear. Over here, a common pattern is for a fanning pattern. And when you see a fanning pattern, that's an indication of a growth or decay model. So you'd want to use an exponential rather than a linear model. And again, this is a pretty common pattern. If you don't see a pattern, then it's likely that you have a pretty good fit. Other things you might see in a residual pattern is you might see outliers showing up in a residual pattern. So these are residual plots here, and we can see a curved pattern, but we can also see some outliers showing up, and those outliers become very influential to our model, and so we want to be very careful about them because they can completely distort a model. If this point was moved here, we would get a negative trend rather than a positive, so we can see that it would be very influential. And this one point is influential because we have a perfect line otherwise, and so you can see that it's drawn the regression model away from where it should be with this perfect line. So just be careful with residual plots. They're just a nice indicator of whether we have a good fit in our model.